In case you're not aware, the Quixel ecosystem set of tools is freely available to anyone with an Epic ID. This is especially good news for students and educators looking to integrate new tools into their classroom. If you go to the Quixel YouTube channel, you will find a new playlist called Mixer Fundamentals. This is a great set of videos ranging in length between 2 minutes and 8 minutes. This is a great set of videos that take you through a great many of the tools inside of Mixer, including things like gradient position, curvature, normals, projection modifiers, pattern components, noise components, and many more. This is a great way to learn Mixer and to integrate photorealistic textures into your Unreal Engine projects. You'll be able to utilize the entire Megascans library as well as paint directly on 3D models. If you're looking for amazing new tools to integrate into your curriculum for your next academic term, this would be a great place to start learning Quixel Mixer. Once again, it's free, freely available to all your students, and a great, amazing tool to utilize a massive library of not only textures, but also 3D assets that are photographically scanned at the highest level of quality. We've also recently released a beautifully developed PDF called The Creator's Field Guide to Emerging Careers in Interactive 3D. The purpose of this guide is to serve as a field guide to emerging careers and skills in interactive 3D and a roadmap for students, administrators, educators, and job seekers that covers the entry-level Unreal Engine skills needed to join the workforce. It's designed to help people start their journeys with Unreal Engine and interactive 3D. This guide will help advise teachers as where to begin teaching Unreal Engine and which competencies to focus on. It'll help introduce students to emerging careers in interactive 3D and the skills those careers require, arm job seekers with a roadmap to share their knowledge in interviews and as they start their career journey, and also to illustrate to hiring managers what Unreal Engine knowledge new recruits need to have, and to prepare administrators to understand the demands and skills across those industries. As you can see, it's a beautifully developed document, and if you want more information about this guide or want to learn where to download it, just go over to unrealengine.com news, where you will find a blog that shares all this information as well as the download links where you can get the guide.
Here we go. Hi, everyone. I'm Tom. Welcome to the Friday Educator stream. Happy to have everyone here. Today we have a really cool show. I'm really excited about this show today. We're going to be talking to three of Epic's own programming team, and we're going to discuss kind of what it means to be a programmer in Unreal. And kind of dive into what the day-to-day life of an Unreal programmer is, and kind of how they got there, and really just kind of open the door for this discussion. Because often we don't get to really dig into what it means to be a programmer. Often we're kind of we kind of maybe veer towards the graphical side of things. Quite often the characters and the particle systems and the volumetric lighting, it looks good on a stream. So maybe sometimes the engineering side and the programming side of things is a little underrepresented. And it's such a huge career field for students going into schools. So we wanted to bring that representation of that entire side of the industry out today. Help educators get to know what programmers are doing, help students understand what it means to be a programmer, and kind of see what this career is like and what that journey is, and maybe even give some advice on how to make it better and how to help your students kind of tackle the next generation of programming challenges. So we've got, of course, to my over here, I don't know which way with the flipping of everything, we've got Mark Flanagan, our
Hi there.
EMEA education evangelist. Myself, Tom Shannon, I am the technical artist on the education team. And today, Louis Cataldi will not be joining us. Louis is out. He had a surgery this week, so he's recovering. We'll allow that, at least this once. And so I'll be your host this week. I'm really happy to do this because this is something that, as a technical artist, I sit in between the artists and the programmers, um, and so I've got a lot of respect for these guys, and they
Without
build all the
programmers,
cool stuff that I get to use as a tech artist. So
yeah,
uh,
we wouldn't see anything on our screens if it wasn't for programmers.
whatever would those artists do? There's that meme of the artists without programmers and programmers without artists, and both pictures are not a good thing. So with us today, let's see, I'll start over here, I guess. We've got Kyle Langley with us. Kyle is a technical designer on the Fortnite team. I guess I'll go this way. We've got right here, we've got Mr. David Hill. He is our principal mathematician, and he works on the Unreal Engine team. And then right here, we have Mr. Jeff Ferris, who is the technical director of special projects at Epic, which is a super cool thing as well. So we've got these three programmers, and not one of them has programmer in their title. That's kind of confusing. Um, so are you guys programmers? We said it's a programming stream, and we brought a director, a mathematician, and a designer here. So, of the three of you, would you guys consider yourselves programmers?
I guess I'll go first. Yeah, sort of. Yes with an asterisk, right? I mean, just for me, like programming is my mechanical skill, right? It's what the hard skill that I bring to the table. But really, at the end of the day, I don't think of myself as a programmer. I think of myself as like a problem solver. I think of myself as like a creator and a maker. Making projects, making demos, and programming is my medium to express that. But I mean, I don't know. Programmer sounds always a little bit reductive and minimizing to me. So.
So eloquently said. I don't know what to say after that.
I think calling it reductive is a really interesting insight, because it's one of the reasons we wanted to do this, was that when students are first kind of choosing their path, at least when I started, it was like, do you want to be a game artist or a game programmer? And I was like, ew, icky code. So I just avoided that side, and here I am somewhere in between. And so, programming has so many facets that by just lumping everyone in as a programmer, it is oddly reductive to what you're doing. It's just like, oh, you do the code. So yeah, I mean, this is going to be really cool to kind of dig in and see how you kind of focus, because I think people have a better idea maybe on the like art side, like, oh, you can be a character artist or a VFX artist or a animator or whatever. But I think, at least for me, and even until I was in the industry, it was like, there's programmers and I'm going to work with programmers. And that was just like a whole lump in my mind. And it's, as I've worked in the industry, I've worked with all sorts of programmers. And I think that might be kind of a common thing just overall in games, is that no one's exactly typically like all they do is one thing, because there's so much to do. So I don't know. I stole the floor from you, David. So
Oh no, I was just impressed by Jeff's eloquence.
First person to ever say that.
Well, for myself, I do lots of software development, and there is a lot of problem solving. I also think like a big aspect of my job, and probably all of our jobs, is like being a collaborator. And that's one of the things that I feel like I really bring to the table, is I have a lot of training in mathematics, applied mathematics, and I try to deploy that to help people where I can, when I can. So I'll work a lot with other software developers as well as technical artists and other people to try to help level them up and move them forward, or get them beyond little roadblocks that they've hit. So that, but primarily, like the majority of my time is spent in front of the keyboard, the Visual Studio up.
Yeah, that's a great point about collaboration too. I mean, I think writing code is near the end of a long chain of events in order to make something, and a lot of the discussions and the working with other people beforehand is super important and rarely touched on.
Yeah. It's also, our code base is so big that you have to, even if you just want to do software development, you've got to talk to a lot of other people while you're doing it. What is this bit? How does it work?
Mm-hmm.
Yeah, and our systems are so ridiculously integrated. That's as on our team, it's so important that collaboration happens, or we end up with these kind of siloed things that they're not as good. They get so much better when there is that collaboration. So Kyle, your title is a technical designer on Fortnite. Can you tell us what the heck?
Well, yeah, I mean, my career started as a designer, as a gameplay designer, where I worked heavily in blueprints and not so heavily in things like Excel, getting data getting data ready, and effectively just setting up the content that was already created from like the base classes and everything created from the engineers, the gameplay engineers. And I had experience programming, and so I sort of took it upon myself to start writing scripts, start using little things to make our day-to-day life easier when it came to the massive amounts of data that we had for Save the World. I just sort of kept an eye on what the code was doing and asked a lot of questions. And fortunately, the engineers at Epic are always willing to share thoughts, ideas, and direction, which led me to a point where I got permission to start helping out with very minor cases of gameplay code. And I sort of just facilitated a junior role where I was able to take other designers' ideas or thoughts and express them in a way that an engineer would be able to, I was able to translate those kind of things into sort of, let's say, the programmer speak of, this is what we'd like to do, but, this is the reason why. So I'd spend effort debugging, figuring out the hole in the problem and try to find a solution or a point at which we could start to attack the problem, and then work with the engineering team to get that rolling. Programming is one of those things where I would consider myself one as in my heart. But as a career, it's one of those things that there's a lot more time I need to spend in the career space to be, let's say, get the title of programmer. So for now, I sit in the middle ground of the designers and the programmers, and I do my best to facilitate both sides, while actively, working to be that, let's say, that full-blown programmer.
So when you started out, it sounds like you hadn't chosen the programming side. You kind of discovered that as you worked and found that was something that you were talented at and gave value to the team.
Well, I mean, talented is a strong word when it comes to programming anyway. It's a long road, and the thing about it is that it had been
dedicated enough, maybe.
Yeah, you have to persevere through a lot of struggle when it comes to programming, and there's even people in chat right now where they're talking about, I'm creating this thing, but this is happening, or I'm doing this and this is broke, or that. And the answer to a lot of those questions is, we'll persevere and keep trying new things, or look them up, or whatever. And I didn't go to college, so my education was look them up and do your best to solve it. With that said, it's taken me 8 years to get here. So college might be a good option for people. For me, it about doubled the length of education through hardship, let's say.
Through learning.
Yeah.
And it is the learner's journey. And often school isn't exactly right for everybody. I myself had trouble figuring out what school I wanted to go to. I ended up going to an art school to learn how to 3D model, and ended up writing shaders and tools in Python and stuff. So it's your career and your journey often is is discovery, because like I've said, you don't know all of these things that are available, and you don't know what you can do and what you enjoy doing. And
Yeah, and then, when it comes to game dev as a whole, what you said there, what you enjoy doing. I started out in level design. I did art. I did animation. I just tried to poke and prod at all the different assets and figure out what it was fun. And programming happened to stick.
nice. So I think what we'll do is we'll kind of do a little roundabout. David, Jeff, and Kyle have brought some stuff to show us, just to kind of show what they've worked on, what they do, give you some insight into each kind of their silos within Epic. Because Epic's kind of a weird place. We're an engineering firm that makes a big, giant piece of software, and then we also publish games and make games with that, and we license it to other people. So we have all these kind of odd arms that maybe don't exist in every game company, but I think they exist in some form in a lot of them, and just really to give an idea of what people are doing once they actually start their careers and spend a few years making that journey. So I guess we'll start with Kyle here. I think Kyle's going to show us a little bit about just understanding, helping our audience here understand a little bit about what it means to program in Unreal and how to get started. And then we'll talk a little bit about the differences between working in Unreal and Unity, and just we want for people who have joined the stream that are like, oh, I want to get started with that, but maybe have been a little bit hesitant because it's maybe overwhelming. I think Kyle's going to show that it's really, really straightforward, and especially if you've ever used another game engine before, you'll be like, oh, I can do this. I hope. So without further ado, Kyle, why don't you go ahead and take over the screen here, and I'll see if I can manage our transition fairly smoothly. There we go. All right, we can see you. You're ready to go.
Cool. Yeah, so this is the absolute, how do I get started? This is the absolute baseline of, I want to get the source code for Epic, or for Unreal Engine's Epic, or the Unreal Engine from Epic Games GitHub. If you go to the GitHub Epic Games sign up page, you'll see just the instructions. You need to go to Unreal Engine, register an account, create a GitHub, and register the GitHub with your Unreal Engine account. Once you get through that process, you can actually go and get the source code from GitHub. It's important before you do it to, one, read all the instructions or guidelines here. It supports Windows, Mac, and Linux. And we support development for all sorts of platforms comparable to other game engines out there. From this point, you'll probably use something like GitHub for Windows, or Git Bash, or any sort of Git thing to clone down this repository. You always want to go to the tags and see what the most recent release is.
This is something that has caught me a few times, because by default it's set to branches here.
It is, yeah.
And I'll end up, you'll scroll down and be like, wait, where's the latest?
Right, and we have all the branches for all sorts of things that are not necessarily related to, I just want to get started with Unreal. So tags, the newest release, that's always the best one to go. When you get that, that's the point at which you will get your Unreal Engine source here. There's instructions to run the setup bat first, and then when this completes downloading, you then run the generate project files, which creates your SLN. This is the Visual Studio project, the solution. From here, you would open that, and you get Unreal Engine 4. And its host of secondary programs. These are used for all sorts of different things. This here is what matters. You do have to compile the solution prior to using it.
Mhm.
When you do that, I recommend that you probably compile first in debug game, debug game client, or sorry, debug game editor. And this will allow you to actually be able to debug your game code. If you do something like development editor, the compiler might optimize some of your stuff away and make debugging more complicated. So typically I usually just run debug game editor when it's just the general everyday development.
Are there any reasons you wouldn't want debugged? Maybe it adds a little overhead.
It's performance. Development's going to run a bit quicker than debug would. But it optimizes away things that you potentially would want to be able to look at, especially if you're in the active case of developing, where you're stepping through lines of code, you're trying to see what's changing and whatever. And if you're in development, some of those things changing might actually come up as optimized away, so you don't know the value of them, which makes your life a little bit more complicated in that scenario.
That makes sense.
If simply you want to run Visual Studio and just run a little bit quicker in the environment, you can run as development. Either way, you need to compile first. Depending on your processor and your computer setup, this can take time. The last machine I think I had was an i5, and it took about an hour and 20 minutes to compile. The machine I have now is significantly faster, but with a much more expensive price tag on it. So something to keep in mind that, getting started here, typically for getting the engine going, does take a bit of time and it does take a bit of effort. There are solutions out there to make your life a little bit easier if you have extra computers laying around the house. But for most people just getting started, you just need to compile the engine first and then you'll be ready to go.
And this is, getting the engine compiled the first time. It does take a while, and it's something that you'll have to do when you upgrade your engine each time. And this is something that needs to be really clear with your students up front if they're doing this, is not to wait until the day before the assignment is due, because they won't even get the engine compiled in time.
Yeah, and if there's any educators out there who are attempting to set this up on the school's machines, this will take a decent amount of time per machine to get ready. Now, once it is done, it's fairly straightforward and fairly quick. But the initial download and compiling is it does take time. Secondary to getting the source code, and I wanted to bring this up for those that don't need to get into the engine source code, is through just the Epic Games launcher, to where you can just go to Epic Games, Unreal Engine, go to your library, and simply add an engine version. You select the engine version you want, install it. When you install it, I recommend that you go to options and you check and uncheck the things or lack of things that you don't want or want. For me, I get the engine source, I get debugging symbols, and then I don't use Android, HoloLens, iOS, Linux, Lumen, or TV OS. So I just uncheck all of that. As you can see, they come with a fairly decent size of storage that if you aren't using them, you probably don't need to download the extra stuff. But
and if you're an art program, or you're not teaching programming, if you can choose not to include the engine source and the editor symbols for debugging, and not have those target platforms, and you can get the engine installation down to a fairly reasonable size, so you're not downloading all 27 gigs of the editor symbols all over the network.
It is important when you develop from the I'm writing code, even in the gameplay framework side of things, that if you get the editor symbols, it's going to make your life a bit easier, because there's times at which you're working with the gameplay ability system or you're working with the animation system, and you do need to get to a point where you want to see what the values are in the engine, or from the engine source. The editor symbols, the 27 gigs that come along with that, is very much worth it. I would highly recommend that you get that in place.
Good advice.
from there, it's really straightforward on both sides. You either launch through the Epic Games Launcher or you launch through Visual Studio. In either case, you're going to be met with a screen asking you to make a project, and as mine comes to be, I'll show you what that looks like. Okay.
The
So
visual
you'll be
splendor of programming.
yeah, you'll be met with a thing here. I have a recent project called Bug Report, which I'm sure has very interesting things in it. But you would create a new blank project. You would also, depending on how you've done your install, you might get templates. These templates would be something like third-person shooter, the first-person shooter, VR templates, vehicle templates. I would recommend that pick one that fits for the exploration of it. You'll get the base template. You'll get a character class or a vehicle class or something that at least gives you a native a C++ representation of where that project would start. It isn't by no means the actual starting point I would recommend most real legitimate projects should take. It is an excellent starting point for those who are, let's say, migrating from another engine or are just curious about how C++ may work in Unreal. So
Yeah,
in this
absolutely.
case,
They can kind of get you to a nice starting point really quickly. Once you've kind of mastered and understand the base classes and creating those,
yeah,
they become just a really nice resource to skip some of the kind of boilerplate. Do you get those templates when you get the GitHub version?
you do. Part of the setup.bat will download those. My version that I have at home, I delete those because I don't need them. They will be there.
Cool.
Again, it's one of those things like we were discussing, do you need to get tvOS as 7 more gigs of a download? I don't need the templates, so I delete them. From here, you'd create a C++ class, maximum quality, or whatever you'd want to do if you had a scalable 3D or 2D game, or just maximum quality. Ray tracing could be enabled. Are you making desktop or mobile? And do you want to include starter content? My option is no, because I have deleted it. Again, you'll be able to have the option here to include starter content. This is just very basic meshes that come with the engine. We have so much free content these days that the use case of this isn't necessarily as strong as maybe it was a couple years ago. But up to you. And then you choose the location that you want to install this. Typically speaking, I put it in the same location as the engine is installed. So C Unreal Engine for me. And then, we can call this edu. And this will actually put, as you can see, it'll create the project right there in the same directory. And then the thing that's nice about that is you can use the same Visual Studio solution to govern both your source code and your game project without having them be in separate folders and have different generations and things. I have found this works very well. When you do this, it'll ask you to reload your solution because it detected a new project. And that will take however long Visual Studio wants to take to do that.
And a lot of this stuff is kind of the first time around. Your
This is
first
very
build
much
is going to take a long
yeah.
time. Your first load, Unreal Engine has a lot of it does a lot of stuff the first time you open a project or an engine.
Absolutely.
But then
Yeah.
after that, it tends to be a little snappier. What I'm trying to say too is you're not looking at a 5-hour compile every time you make an engine change or anything. This is kind
nothing
of
like that.
a one-time thing.
The bulk of your time, depending on it depends a lot on how much engine work you're doing. But for the average small team of, few engine adjustments here and there, it's really not that bad. And if you grow to a bigger team, there is solutions in place in which you could make that a little bit easier on yourself. The truth of it is that the code base here is massive. It takes time for the compilation to happen, depending on what it is you're changing. The general use case for most users is this. I've compiled once, I've made a game project, I now have the source code if I want to merge something or bring something over or change something, and then you understand the time it takes to do that. When you have your game project, we have our EDU here, and this comes with the normal project stuff that you would see. Typically, I like to set this as my startup project, so when I launch from here, it's automatically going to load my game. And it comes with just a couple base classes. You get your game mode, which is very empty, just a game mode, and your actual project. And that's it. It's very straightforward. If you get one of the templated things, you'll get more stuff. If you do the first-person shooter or the third-person shooter or anything like that, you'll have a character and a couple other things in place for you. Because this is an empty project, this is where you start. From here, you load up the editor and start following along with the multitude of tutorials that are available. Because this is where the stream could take that 10-hour shift to.
Oh, absolutely. Yeah. I mean, this is where your journey starts.
Exactly.
But I think so many people are kind of a little intimidated to know what it's going to take, and to see you get there in 5 minutes is a little
it's
reassuring.
not that bad. And the majority
if you're
of
used
this,
to code, then I think a lot of this might look fairly familiar. If you're coming from something like C#, C++ has a little bit of added complexity with headers and stuff, but
it does. The thing with Unreal's version of C++, and I'm actually comfortable saying that I do think Unreal has its version of it because of how the gameplay framework works with our garbage collection and everything else in place, that the mystery of it has been highly diluted down to a very manageable, very understandable point to say, here is your base set of things to use. And as you develop the use cases of those, you'll be able to develop your experience in C++ and then be able to sort of branch out from that. With that said, computer science knowledge coming into this is always a benefit. There's never a point at which you know too much computer science or something like coming into Unreal, right? Like if you go to school for computer science and you want to get into game development, this should be very approachable for you. And those that aren't in a computer science field or are just interested in game development, it might be a good idea to take the rudimentary computer science start from somewhere where you sort of get the idea of programming prior to jumping into the massive game engine full of many abstractions and things that will be confusing if you just hope that you get it. That was one of the things that I did poorly, is I sort of just dove in and I spent a lot of time just banging my head against not understanding what was going on. And it wasn't until I sort of wound back and started from a more basic point that I was able to get back into sort of understanding this a little bit better.
Fantastic. Well, thank you for showing this.
And
kind of pulling the, I don't know, it's not the wool from our eyes, but it's really, I try to explain this to students and educators because there's really no other tool out there. I can't go get the code for Photoshop or Word or Max or Maya. There's no other tool that provides that ability. So I think often folks might look at Unreal and they see, oh, I've got to go get this whole GitHub thing and I've got to work in Visual Studio and learn how to do this. And I think what I've seen here is pretty much everything you need is set up. You download, you run a batch file, you wait, and then now you have this incredible resource where you can, dig into the actual engine code to learn how things work. And what's when you're in the 11th hour of your project and there's that one thing that's formatting a string wrong in the parser in the engine, you can just go fix it, compile, and you're good to go.
There's a lot of flexibility in this, and and that's the power of the source code. Realistically, though, the power that comes with it is, at least from my personal use, often unused. I typically keep the source code around for no other reason than an easier access to debugging. The truth of it is that heavy engine work takes a lot of people. It takes a lot of time, and the nice thing about having the source code is the small changes, is the little things along the way, or the most benefit I've seen is there's a change on GitHub and I only want that change. I don't want to get the new binary and move my project to the new thing or blah, blah, blah. I can just take the code that I want, move it over, compile, and I'm good to go. With that said, though, I mean, you're free to explore this whole thing. It's a lot, but it's there and it's available.
Yeah, and so, from an educator perspective, this just gives you the keys to the kingdom. So if you're teaching gameplay programming, you have our gameplay scripting C++, and your students don't have to learn memory management and garbage collection and any of that, reflection. They just
Not
learn
for a
to
while anyway.
use some macros and follow some of the templates that we have, and they can get started. If you're teaching like software engineering and you want to teach like data processing or how to build an importer, you have all the modules in the entire system, and so you can teach your students how to build these things in a real production environment. Like, this isn't some arbitrary tool either. Like, Unreal is a living production environment that's being used by hundreds of thousands of developers every day. So it's a real world example. So when you're teaching their students this, they go out to their first job, they'll be comfortable with these big, quickly modified code bases.
Yeah,
it's hard to overstate, I think, the value of having that source code just as a reference, right? Just a learning reference.
As a reference, it's a massive benefit. Yeah.
I mean,
I do like blueprints,
Yeah.
and I always have the engine source, because if I'm wondering how something works, I can double click a blueprint node, and there's the code for it, so I can see exactly what's going on. And when I'm like, does this input do anything? Oh, I see. It's not in this case. Okay, great. Mystery solved.
Yeah. I mean, just the exposure to being able to look at what's happening for real, the actual code that's being run is very, very helpful. I went through back in the UDK days where I was in Unreal Script. Many headaches were had about, well, what is this actually doing? And there's other similar problems with other engines too, where it gets very difficult to find the actual problem. And more so, if there's an actual engine bug, it's not going away until somebody else fixes it, and that's a very frustrating point to be in. But yeah, I mean, the last thing I wanted to mention is our use of Visual Assist at Epic. I do not know an engineer at Epic that does not use Visual Assist. It's effectively how we navigate the code base without using the built-in IntelliSense and the searching. Visual Assist is very quick. It comes with many cool hotkeys and options to just get through the code with a little bit more grace than Visual Studio would typically give you. You do have to buy a license. It's affordable per year.
There is an academic license. I think it's $49 a year for students and faculty.
For a piece of software, for how useful it is, it's I mean, I would recommend it even if it was expensive, but it's really not that bad. And this would be the last little bit of getting started with Unreal. Is Visual Assist is a very, very helpful thing. If you don't have the money to license it, it is in no way a deal breaker. It is just a very nice to have, and something to think about as you get into the source code and as you start navigating around. It's just very nice.
Yeah, I'll second that. I've done a lot of work on like events and remote deployments of software, and anytime someone IT sets up a new machine, my first question is VAX on it, and if it's not, then go for VAX on it.
Yeah, take it back.
And for those that are listening, when you hear "does it have VAX on it," now you know that's Visual Assist X.
Visual Assist X, yeah.
I mean, it's so important, and even Epic is not typically like, go buy this software. We even have it on our documentation page on how to install the extension and how to get it to work with UE4.
Yeah, I mean,
so
on their
it's
homepage,
certainly
it
something
screams
that
at you.
should
you
be
know.
considered. Right.
So it's very well integrated. It's very usable. It's nice. But again, it's not one of those things that you absolutely have to have it. Visual Studio on itself can navigate the code. I do have a friend that is learning to program, and he doesn't use it, and I yell at him every time he doesn't, but he seems to navigate just fine through it. So
Awesome. That's some really good advice. Yeah, it's not terribly expensive, and it really does makes day-to-day life developing in Unreal so much smoother.
Yes.
And that's key to having success and enjoying yourself. So hopefully you can figure out a way to get your hands on that. That was fantastic, Kyle. Thank you so
Cool.
much.
Yeah, you're welcome.
I'm gonna go back to gallery view here.
Okay, I'll stop sharing screen then.
All right.
Okay.
There we go. That's really cool. Thank you so much for demonstrating that, because it's I try to talk to it a lot when I talk to schools, and it's tough because I don't do it on a daily basis. So it's good to see that my assumptions when I'm out there being like, it's easy. It's a long one time, and then after that, it's it's a batch file. It's like a download. It's a batch file. It's good. I did it a while back, but it's been a while, and it's good to see that it still really is. You go to GitHub, you click the gimme, you run a batch file, wait, and then you've got the whole source code to this massive engine, which is just so super cool. And then if you're intimidated by that, just get the launcher version and just work in this kind of subset of C in your projects. And there's so many kind of in-ramps for educators that are trying to build curriculum on all sorts of levels. There's, and then of course, we're not even talking about blueprints. So if you don't want to do code at all, you've got a fully visual system with no syntax. It's fully in the editor. You don't need any other IDEs or anything. So there's just so many ways for educators to get started with programming and get students to start writing code.
Yeah, I mean, the starting point here is more from the, I kind of want to take game development a little more serious, or I have been taking it more serious, or I've been using code in other engines, or I'm a computer science student, or anything like that. If you don't have any computer science knowledge and you don't really want it, start up the editor, get Blueprint going. It's a much easier interface to get things working. Computer science degrees are a minimum of 4 years. Typically, getting in the industry takes a master's. Mostly. A lot of the engineers I know at Epic have masters at the minimum. It's a long road to learn to program. Mm-hmm. So, understand the time it takes, and then, but if you just want to make stuff happen, Blueprint's a fantastic starting point.
Do you think the Blueprint's a good way to start to understand the sort of logic and even just the way in which algorithms work?
I think Blueprint is a very good point to start learning to solve problems.
Yep.
I don't think it's necessarily the greatest point to start learning computer science. There's some falsehoods in Blueprint that teach habits that aren't necessarily true in coding. With that said, there is a lot of similarities in the structure, the mental flow, how a problem gets solved. So I think it's a really good starting point for like getting your brain used to solving problems in the, let's say, programming sort of way. But it is a scripting language. It's not, but there's enough difference that you can't really say they're equal. They are comparable in some ways.
Cool.
Awesome. Thank you so much. So, Jeff, do you have a master's?
No, I have a bachelor's. but I'm old. But I'm old. We didn't need masters back then. So.
And that's a good point. Like, things have changed a lot. And I think the bar has changed, especially, we're going to talk to you, Jeff and David, about, I think, a little more of the engineering side of things. And You know, like Kyle didn't start with a master's or a PhD. He just went in with blood, sweat, and tears, and made it happen. And you know, that is a route. But you know, for students, they have to know that it truly is blood, sweat, and tears to go there. It always is. It just depends on whether
it is not a route I would recommend. If you have the ability to go to school, financially and otherwise, I would highly recommend you do that first. I was not in that situation. I was a very poor student in high school. I couldn't get a scholarship. I couldn't afford going to college, and so I didn't. But you still have to make a career for yourself, and so it just took me a lot longer and struggled for it. But
you're
I mean,
stronger for it. Look at that.
There's something cool about it
armor.
too. I mean,
I would totally agree with that recommendation. Actually, like I don't, you know, I got a degree and I don't regret it at all. I do think that my first year in the game industry, I learned probably 3x what I learned in college. But I don't think I could have made that progress without the college experience in the first place. Like if I was starting from scratch, that would have been, yeah. So I think it set me up for success.
So your college set you up for when you started in the industry, you were able to kind of
I was able
to and learn with it rather than so it made you kind of a better learner and a better kind of a junior programmer, whatever you were.
Yeah. I mean, the story I told a couple times has been my first day was at Volition in Champaign, and the first day I sat down and I hit a crash and went and talked to the lead programmer, and he came over and he's like, "Well, did you run through the debugger?" And I was like, "What are you talking about? Like, I never ran a debugger." Right? And I was surprised he didn't fire me on the spot. Like, how did they, you know, like how did I get through college without ever having run a debugger? You know, so but I mean, he showed me and kind of ran me through it, and 2 weeks later I was a debugger master, right? So, so I think, you know, it was like learning how to learn, right? And exploring what you want. Like, I mean, I went through two different majors, you know. So I explored something and rejected it and came back to computer science. So.
Mm-hmm. Yeah, I mean, so much what you learn in school really is outside of what you think you're going there to learn. I remember going to art school and being so frustrated that I wasn't doing art in every single class. And now I'm like, man, I kind of wish I had more math class in that art school. It would have helped me out a bit more. So now, Jeff, go ahead, Mark.
I was going to say, I studied architecture, so I have no idea what I'm even doing here. But I'm going to share some slides, I think, for Jeff. Is that correct?
Sure, yeah. So I was going to talk a little bit about some of the different programming roles and kind of break down what programming overall means a little bit more functionally.
So currently wait, I have to go look at your title again here. You're Technical Director of Special Projects.
Yeah.
That's the wrong screen.
No, don't show us that. No. That's the secrets. You've shown them all the secrets.
I had an inception moment there. Sorry about that. Share screen.
So tell us.
Selected.
What are special projects? Because I think they're cool.
So at Epic, right? You know, we have the engine.
Start it again.
You know, see, I couldn't get it to work either. So,
sorry about this.
Just that day.
Yeah. So we have the engine. We have our games, but we also, I mean, our games don't necessarily cover the footprint of everything we want to do in the engine, right? And so we have, you know, another small team, kind of a strike team that does interesting projects that can have, you know, opportunistic partnerships, or, you know, interesting or dog fooding, you know, engine systems that are just coming online. So a lot of ways we're sort of the tip of the spear on new things that are coming up before, you know, just to exercise them and make something with them before it goes into the engine proper. So
real quick, you used a term there that is pretty important to Epic, and I think is kind of unique. Again, because we build this engine that we license out to people, and we also use. You called it dog fooding. Can you really quickly tell?
Yeah, absolutely. I mean, the you know, there's this old phrase of, you know, eating your own dog food, right? Like, you know, a company needs to use its own products. There's a famous example a long time ago, like apparently Microsoft didn't use Visual Source Safe, and we used to use Visual Source Safe as source control, right? And it showed because it was garbage. Sorry, not to put too fine a point on it, but yeah. So I
Pretty
mean,
fun.
I personally, and I think we as a company think it's important to use our product, right? I mean, we make this engine, but we use it in Fortnite, and we use it in Paragon, and we use it in Gears of War, and you don't understand your customer better than you can't understand your customer better than actually being your own customer. Mm-hmm. So we try and find ways to make that happen, and I mean that helps us, but also we get to work with other partners, right? Like here on Robo Recall, we were just stepping into VR and putting our VR support into the engine, right? And so we had a partnership with Oculus, and so let's make a VR game. So we did, so we had a small team of about 15 people, and in about a year put together Robo Recall. That was a super fun project. That was you got to learn a lot. That was a great team. That was a lot of fun. Next slide. So some other examples of stuff that we've done, focusing on digital humans. At SIGGRAPH 17, we did a thing called Meet Mike. So this was we did a digital human of Mike Seymour. Didn't quite get across the Uncanny Valley, but it still looked pretty good. Go to the next one. So we actually had like a real-time demonstration. So it was like a real-time facial solve that Cubic Motion had done. Three lateral, I went blurry. Three lateral, made the head model, the head rig off a scan off of Mike. And then go to the next slide. And we actually ran like this talk show at SIGGRAPH where he was in this rig and doing real-time facial capture and animation on this digital human, was talking to another real-time facial capture on this very cartoon-like digital human, and he was interviewing people in the industry. And this is one of those projects where we look back on it and go, were we insane? Right? It's just crazy in hindsight, but a lot of good memories on that one. I can't believe we pulled that one off. But it's kind of the thing we do, Next slide, please. So I'm gonna jiggle the handle here on my video. We did the Fortnite replay system for GDC in 2008. We showed off at GDC 2018. That helped out the Fortnite team and developed some new tech, for the replay stuff. Next slide. GDC last year was the Chaos demo. So we worked with the physics team. They had this new destruction technology that they wanted to develop, and so we jumped into the project with them and like, hey, let's make something cool. So we did this using some of the Robo Recall assets. Had this really almost film quality real-time destruction. It was playable on we actually played it at GDC on like a 40-foot LED screen, using Vive controllers. That was a super cool installed experience. A lot of fun to work on.
Yeah, it was. It was such a cool experience with the like tower of monitors, and I was like, where is this game at my Dave and Buster's? Come on now.
Yeah, we had like $200,000 in equipment, like right behind me. For
I knew the answer.
for the development of that for like 2 months, since like I had radiation burns from behind. Next slide, please. And then the Mandalorian was a really cool project we worked on. We wanted to get into the virtual production space a little bit, and how can we take Unreal and use it in non-game aspects, right? So we partnered with ILM and with John Favreau and his team, and this. I don't know if you've seen articles about this, and there's some stuff you can Google, but it was like this giant LED wall that the cameras were shooting into, and then we in real time distorted the image, the 3D image, so it looked proper from the perspective of the camera, which meant that they got something like 30 or 40% of their shots in this volume, without having to go to post, which is pretty amazing, right? Like that's, they made a Star Wars TV show with all these awesome visuals, and didn't have to spend years in post making every single image look like the movies.
Right.
So I thought that was a huge success. Yeah.
Spend a whole episode on a planet that's always at dusk.
Exactly. Yeah. So there's a couple pictures of this. You just kind of scroll through. Next one. There's one more. Then we did a second version of this at SIGGRAPH. So this is kind of the upgraded version. So we spent quite a lot of time getting the virtual production team up off the ground. And now that's a whole team in Epic, right? So we kind of bootstrapped it, and now that's a big pillar and a big vertical in the engine. Next. And then the UE5 stuff that we just released this spring. We partnered with the graphics team on Nanite and Lumen, and said, hey, let's make a demo. they're making this new tech. We got to show it off. Let's get a bunch of artists in there and, you know, shake out the bugs and see how far we can push it. And I think we pushed it pretty far. I was pretty proud of how this turned out.
Yeah,
So I think
it should be. It's absolutely mind blowing.
So there's a couple screens here in a row. Just want to roll through them. Yeah, and there's videos and stuff. You can find all these online if you're interested in seeing more.
I have a feeling that our audience may have stumbled across
Yeah.
the UE5 videos and may have paused and rewind them over and over again. And if you haven't, you should.
Mm-hmm. Cool. So, I mean, these are kind of interesting from you can stop the slides. Thank you for running those. So it's kind of interesting, like on special projects that we get, like, I guess, let me just rewind a little bit. Like throughout my career, I've had a lot of exposure to different programming roles and different aspects, I guess, of you know, engineering games. And when I first started at Volition, we had everything was kind of full stack, right? It was just, you had a game team and they did everything, right? Like the game team wrote, you know, the file code, you know, for all the different platforms. You know, they wrote the graphics, they wrote the gameplay, they wrote the UI, right? It was just kind of one game team that did everything, you know, top to bottom. And that worked great. Like if you had a single project team, that was fantastic. But when you're trying to run multiple teams in a studio or multiple projects at the same time, you know, you get this problem. How do you share? So when I came to Epic, we had, you know, that was my first experience in actually having a separated engine team. And that was interesting because I came off of a team of probably 20, 25 programmers on the first Saints Row into a team of, I think I was the 5th programmer on Gears of War 1. And, you know, comparable quality projects, which blew my mind. But, you know, working on this technology base and having this engine behind you was you know, amazing. So I spent several years of my career, you know, on the gameplay side of that, working on the gameplay, not really touching the engine much, you know, once in a while when you need to. But then UE4 came around and I kind of switched and worked on the framework team on the engine, which is kind of the most gameplay of the engine teams. So I spent several years on that. Then eventually landed on Special Project, which is this really interesting hybrid of both. It's like we're most closely attached to the engine team, but we're making game-like demos a lot, like in client demos. So really like a lot of what I'm describing, there's kind of this divide between like engine programming and game programming, right? And that's one kind of interesting way to carve it up. But the big difference there between them, I think, is your customer, right? And that influences a lot of stuff in how you think about what you're doing. So like on a game team, you know, your customers are and buyer, right? The player. You know, the player doesn't see your code. The player doesn't know what garbage is under the hood, right? Like, I don't think I shipped the game up until like Gears 3 that didn't have a, you know, if level name equals blah, do some special garbage, you know, in there somewhere, right? Because hack ship games.
What are you talking about?
Yeah.
All games are completely bug free and all code is commented.
Yeah, and that's what makes them bug free. Yeah, so I mean, you have like your responsibilities to that end player, right? And really your product is the final runtime, you know, the final executable and the final content, you know, that's on the disk or, you know, gets installed on the PC. Whereas an engine developer, you know, you're making middleware in the most traditional sense, right? Your customer is other developers who are going to use your stuff. So you're making tools and not necessarily a product. So it's a very different mindset. You know, the code in that sense is your product, right? Like someone else is going to download your code and use it and modify it and extend it and build on it. And there's different requirements for how that code needs to be, you know, for someone to succeed you know, for your customers to be successful. You know, you need to, like, one of those things is supporting many roles on your dev teams, right? Like your engine programmers need to think about all the different ways that someone is going to use the engine, right? Like you need to support designers, you need to support your artists, your tech artists, other engineers, right? You know, your code can't be total trash.
Well, and you know, part of special projects is to kind of discover that, because when we make these tools, we make them with the best intentions, obviously, and we think we know how people are going to use them, and we think we know, and then, but we won't really until we put them through some sort of gauntlet and actually try and make them do what they're supposed to do in the real world. And that is something, you know, you do that with a game with like testing and stuff, but how do you do that when you have an Unreal Engine really the only way is to dog food it and to
Yeah.
make something and to test those assumptions. So
Yeah.
it's,
I mean,
it's
like everyone tests, right? Like you always test and make your little test level or your little test situation. And that's one thing. But then someone else using it in anger is when you know, right? And when you know that you messed up, then you got to fix it, right? And the goal is to tighten up that feedback loop as much as possible, right? Like you're going to get that feedback, you're going to release it to the customer, and they're going to come back and say, hey, this is bad, this is bad, this is okay, right? But they're angry, and it took 6 months for that to happen. Whereas you'd be much better making me angry, and I can tell you in 10 minutes, right? So that's super beneficial.
Yeah, and I wonder, I don't know if a lot of people understand that that is something that we not only, we say we dog food, and we obviously have Fortnite that we can dog food a ton of stuff on, and we like to hold that up like, sure, you can do that. We're doing it with Fortnite. But Fortnite doesn't solve for all problems. Fortnite doesn't even use bake lighting. So, that's a huge section of the engine it doesn't even touch. So, it's interesting. And when I started at Epic, I was surprised by the depth of the special projects and how kind of how passionate we were about creating such robust experiences for it. Because I've used a lot of software in my life, and I can tell when they've just kind of run the same kind of like unit test to make sure everything works, where it's like, yeah, sure, the lighting thing works. And you're like, well, I can see it does, but then when I actually use it, it's the worst.
Yeah.
If you had actually re-imported during your test, it fails. And we've all used software like that you're just like, did you use this? And sometimes the answer is no. So it's really cool at Epic that we even have like this whole separate team that is just dedicated to really finding those solutions, and it's got to be pretty damn cool to work on a team where it's like
it's super fun.
You're supposed to make a game that's supposed to just prove a bunch of amazing stuff and make everyone's jaws hit the floor at SIGGRAPH. And then hand that off to all these developers, and then you get to see all the really cool stuff that gets made.
Yeah, well, I mean, that's one of the big things about an engine is you want to support as many use cases as possible, right? Like if you're making a game, like your use cases, and really being overgeneral, like on a game team, is kind of bad, right? Like you may spend a whole lot of time making a system and say, it's going to support all these things, and the designers say, I want to do these two things, and you're like, but I just did all that, right? So that's where, like on a game team, there's a lot of communication, understand your use case, and solve for the use cases that right? Solve the problem in front of you is, I think, good advice on a game team. Whereas in an engine team, maybe you don't have a problem; it's more of a general problem. And at some level, I mean, it's always a balance, right? But you're trying to solve the problem in front of you, but you also want to enable customers to, extend what you're doing or to use it in ways that maybe you haven't thought of.
Right. You can't just solve it for your case. You have
right. Yeah.
Kind of see what the real thing is. And
everyone's going to have their own use case because they have their special needs, right? Like that's like no one's making, let's just make The Last of Us and do it again, right? Like, like that's been done. Someone's gonna do something else cool and do something new and put some new spin on some genre, or I have some new piece of tech and I'm gonna try and push it as far as I can go. And I don't care about this, but I really care about this, right? And you need to support those and think about those use cases. And so I think your best engine systems are those ones that are really broad and can be used in really unexpected ways, right? Like that enable the users and to really push forward, in ways you hadn't thought of.
It's got to be a lot harder to develop and to kind of approach solving problems like that, because like you said, when you're making a game, whatever the code is that makes the game run in the end is the code that works, that ship it. But when you're providing people source code and building tools, the mindset really has to be a lot more robust about building those. And we can't just put in the if statement hacky thing with the, whack to do, that isn't going to cut it. It's got to be so much more challenging to kind of conceive of these tools and build these tools.
Yeah. There's a lot to keep in your head in terms of, thinking about those cases, right? And I think one skill that really helps in that is just being empathetic to the customers, like being able to. I mean, this is kind of a general programming skill that no one ever talks about, right? But like being able to project yourself into the user of what it is that you're making, and try and feel what they're going to feel when using your stuff, right? Like if you can have that sort of internal feedback loop, the dude in the shoulder and the dude in the shoulder arguing about it. I mean, that's the fastest you can do. So even like just thinking about that when you're programming or when you're designing systems is really, really helpful.
Yeah. And as students are thinking about, am I a gameplay programmer? Am I a tools programmer? Again, it's not something I think most 17-year-olds are like, I want to be a tools programmer. They're like, I want to work on the new cool video game. And it's you're teaching these students. I get asked this question a lot for technical art, is like, how do I teach tech art? And it's tricky because people aren't signing up for tech art programs because they don't even know what that means. It's not a thing. And it's not even a thing that I think most people kind of understand early on. Same for programming. I don't think most people kind of know what programming they want to do until they start doing some. And so when you're teaching programming or teaching art and tech art, understanding what all these sort of roles are and being able to help students as they kind of self-identify into their skill set or their happy place in development, and know that like, oh, that is a career. You can keep going that way, and to empower those students. At this point, there's so many different facets of game development that as students kind of show their skill sets, if we can help identify them, because industry is begging for these individuals that sit between the artists that have some tech skills and the programmers that have some art skills, and that VFX guy who can do the Houdini thing. That's all like kind of code and it's all math, but it's all pretty to my eyeballs.
So don't forget audio.
Yes, never forget audio, please.
No, please don't.
First of all, the audio guys get angry. You don't want them angry.
No,
Exactly.
you don't.
Yeah. But
No, because they're
it's
so nice
important.
that it's scary when they're angry.
Audio is so important. Do not ever forget about it. It adds so much. Sorry, I had another point, and then that threw me off.
That's actually,
right.
as an aside, like when working on game projects, that's kind of one of those points where I feel like, oh, it's real, is when the audio starts to get added in and there's menu music suddenly, and now when you kill someone they actually grunt, and like these things, like at first it's like, yeah, it's a tech demo, it's great. For me, it's always when I boot it up and suddenly there's music and there's like some signs of this that I'm like, it's a real game. Hey guys, we're making a game.
Well, it's all about feedback, right? And we always talk about the three pieces of feedback for every player interaction, and one of those being audio is key. So you were talking a little bit about crossover skill sets. And one thing I wanted to mention is one thing we talk about internally, like when hiring and recruiting and stuff, is we use the phrase T-shaped people, right? And being a T-shaped person is desirable. And what that usually means is you have a lot of depth in one area or two areas, but you have a lot of breadth in a lot of areas, right? So it's like you have a thing, you can do it really well, but you could do anything because you have a lot of experience. You can do a lot of things good, you can do one thing well, and and it's being able to be flexible and like that kind of person is great, because that person can go on any team and be successful. That person has a great skill set that you can plug in when needed. So be a T-shaped person.
That's good advice, and it's something that I bore of reiterating when people ask, what students ask, what should I be learning? Everything. You should learn a little bit. You should push yourself into those. But yeah, I think that's really good advice about still focusing on that core thing that you love or that you're good at, but take a little bit of time to spread that out. If you're a character artist, maybe spend some time mastering material so you can get really good skin or whatever that is. Just building that T in today's game development stack, you really have to, because there's just too much to do, and you can't hire someone for every little role. Even Epic, everyone has to wear a lot of hats. Because there are so many hats to wear.
Yeah, and I mean, I definitely want to emphasize like generalist is not a dirty word at all. Generalist is awesome.
No,
Yeah,
no,
like,
generalist
like,
is
like that's okay. Yeah, be that.
No, and that's great advice too. I think when I
Yep.
was in art school, it was like, don't be a generalist. You need to focus on a one thing.
Mhm.
And I think that was advice for back when, I would build the entire model. I'd model the tank, do the texture, I'd rig it, I'd animate it, I'd even make the muzzle flash on the thing. Like that was one person did that whole thing. Anymore, you're like, no, we would never have one person build the whole tank. They wouldn't even be able to figure out the tread system that we're using. Like, it's become such a team effort, and
In
everyone needs to blend across those roles.
in film pipelines, there are actual whole departments of people, generalist department. And
Mm.
what they'll do is they'll get a task which just doesn't fit in other people's realm. It's much easier to have one person to grab this whole thing. It could be a particular shot, and they'll do everything for it. They'll model, texture, light, composite, and having those kind of skills really it does help teams.
Absolutely.
I would reinforce the point that it adds to just a better level of communication. So
Yep.
if you have a generalist, or if you have some of that breadth that Jeff was talking about, it makes it much easier to speak with somebody else about whatever problem you might have, other things you want to communicate.
Yeah, and that's so key on any sort of development, and especially in real-time development, games, visualization, because your feedback loop is so fast, and your software is so fast that often now your bottleneck is the human connection and the time spent communicating. And if you're just going back and forth trying to figure out what widget you're both talking about, that's a lot of time in an interactive environment. So yeah, that ability to speak, or at least even if you can't totally speak programmer, artist, you can, like, I'm not great at Spanish, but I can kind of hear Spanish and I can kind of understand what you're saying, and I can put together a sentence, and it's horrible. But it's there. And so now I can communicate, and I can help bridge that without this, hard wall of communication between
Yeah.
One of
all
the
these
interesting things
skills.
I've seen with generalists is they tend to have, as you say, the T-shaped skills. So they'll be very good at one particular aspect, perhaps, and they'll solve more of the problem in that thing. It could be in, say, lighting rather than compositing. Another generalist could be better at compositing, and they'll solve the problem. Could be exactly the same problem. They'll solve it with their particular skill set, and it's really interesting to see that your deep skill can quite often get you out of trouble from the other things which you have a broad knowledge of.
And give you a lot of opportunity
Yeah.
to move and not be pigeonholed, because the game industry changes quickly, and so the ability to kind of move that deep, that line, that vertical T to one side or another, or even build it so now you're an H shape or whatever it is.
Or a brick.
Yeah, that's going to happen. Like it happens to all of us over time in this industry. And
yeah, I mean, speaking to code specifically, like, don't be afraid to touch other systems, right? Everyone kind of has their silo or the thing they're working on, but it's enormously helpful in one, getting your problems resolved, but also in your learning. If you hit a problem, if you do your steps 1 and 2 of the triage of an issue before you throw it over the fence to someone else. So like if I had an issue and with David's code, I could go to him and say, hey, here's your context, and here's step A and B, and that's where I hit my wall. But that accelerated him probably an hour down the road maybe. And you learned a bunch in the process, right? And every time you do that, you're going to go a little deeper and become a little more capable and a little more comfortable in a different engine system, right? So just having that ability to tread water at least, and not drown in other people's systems is very valuable.
David Hill has never written code anyone's had a problem with. Come on, Chad.
Yeah.
He is our principal mathematician.
I wanted to pick something that was just so ridiculous that we just hyperbole.
It was a funny aside to think of that possibility. So that brings us to Mr. David Hill, whose title is, I think, probably the one that is least common maybe in game studios or maybe most studios, Principal Mathematician. So I
That's a
bet
funny title.
David Hill has a bachelor's and maybe a master's and maybe more. Have you gone the full PhD?
Oh, I have.
Are you
Yes.
Dr. David Hill? Oh man.
But but to the earlier discussion, like I'm a very humble programmer. Like I write code and I try to make it as good as I can, but there are always bugs. There is always a bug, um, which is just the nature of writing code.
Right.
So
There's never perfect code.
not that I've produced.
No, it's especially with a generalist sort of engine like we have. I think there's maybe like perfect code for a game because it's if it your game runs, doesn't crash, and is at 60
it's
frames a
perfect,
second,
yes.
then it's perfect code. Ta-da! You did it. But once someone is like, what if I can plug in this thing in a mocap controller and then I turn this setting over here to 11, and you're like, oh, code's not perfect anymore. So David, as
Yeah.
principal mathematician, what
So-
what is that?
So I took a different path into the industry, but I think everybody's path is pretty unique. In my case, I do have a PhD and in applied mathematics, and I worked for about a decade as a research scientist at Caltech before leaving that world and moving into computer graphics and computer animation. And there I did it first in movies before games. But every step along the way, it's become more and more fun. Which, yeah, I'm super excited to be where I am and to be working with the people I'm working with. And my day-to-day life is really as a programmer or a software engineer or developer or whatever term you like. I kind of feel like we're all programmers on some level. If you're making a computer do something for you, you're programming it on some level. So that's a lot of my day-to-day work. But because I have this training and this background, there are places where I can step in and help other people as they're working on their projects. So I try to contribute as much as I can in that capacity as well. But by no means do you need to have a PhD to make games. Sometimes it helps, but usually it probably gets in the way.
I would say it's uncommon
Yes.
to have a PhD at a game studio.
It's not the path I would recommend.
Your top end graphics programmers. It's not a path you would recommend.
If you really want to make games, I wouldn't say that this is the route you should take. If you want to learn these things and make games, then yes, it makes sense. So I'm currently working on the geometry team, and that is a very sort of tool-centric team. But I was going to talk briefly at first, just touch on some of the things that both Kyle and Jeff have talked about and you've talked about in your conversations. But just to sort of reiterate a few points, and I'll make some statements. Maybe people will correct me or have different opinions, so I'd love to hear those. So first, when I was asked to do this, it was represent to some degree an engine programmer, engine versus gameplay versus other things. And it made me sort of scratch my head a little bit. It's like, well, what is the engine? And I thought about it for a little while. It's like, this is just, I would say it's a very wide umbrella. It's our software code base that powers our games and lots of other real-time applications like the virtual production, the editor, real-time visualizations and things like that. So at the core, that's how I would define the engine. The primary interface for it is the editor, and Kyle had that up earlier, and I'll probably pull it up in a minute or two. But it's just an application for those people who haven't had a lot of experience with it that presents more of an integrated development environment for making these games and things like that. It's shared by the artists, the designers, and the developers, and will all work in it or on it in one way or another. So again, it's the sort of real-time software basis that powers the editor. I would think of as the engine. And then the editor itself exposes lots of tools, specialty tools to help you build the games or build whatever you really need to build. Tools to build the world, like landscape and terrain tools, tools to make the inhabitants kind of interesting, like AI or animation things, tools like other aspects or like rendering and lighting and materials. So in materials, you can do a little bit of programming directly where you make your own materials. That's definitely programming in my mind. There's a large rendering team that's working on all these different rendering features to make sure that everything you have the expressibility, the flexibility that you want in bringing things to life, whether it's being photoreal or more cartoony. There's the physics engine, which is embedded inside the engine. And that's responsible for lots of things during real time. So the clock, characters bouncing around, sorts of queries against the world to figure out where the world is. If you're interacting with stuff, that all goes through the physics engine. But it also has tool-facing things to help set up the work that you're doing with the physics engine to help the game people actually make this building explode or this car bounce or whatever it is.
Right. So the physics engine itself isn't the tool. There are tools that are made to help you interface and use the features of that
That's right.
feature.
So it needs some tooling to sort of expose the features. Like Niagara, the particle system, that's part of the engine, but it's a particle and effect system. It runs in real time, but it also has tools on the other side for the artist to help build their effects. So, and I haven't even talked about gameplay and like all sorts of audio. All right, I said it at least. But it's a very, very wide umbrella, and it has what Jeff was talking about with sort of the stuff that faces the final consumer, the people who are playing the games, as well as stuff that's facing the people who are building the games. And all of that has to be hit by like the engine programmers, whether if they're making a tool for setup or something that has to be super efficient because it is doing some simulation during the game itself, where it's maybe physics has a teeny slice of a brain that they get to do some computations with. So there's a very wide range of sort of tasks under engine programming. And I guess I wanted to highlight that from the education standpoint, because I guess it means that if you like animation, or if you like physics, or if you like rendering, or if you like making tools that really help people sort of express their creativity, all of that can fit under the engine. And as we've talked about earlier, it's a big software code base. It's primarily in C++. I use Visual Studio as my development environment. I know there's some people, you don't have to develop for Windows or in a Windows environment, but I do know a few people who are more idiosyncratic and choose to develop in other, in Linux or things like that. So that's more broadly sort of what I want to talk about from the perspective of tools and engine programming and the way I see the engine. But then I was just going to quickly show you like one of the little tools I worked on to give people more of a sense of what I mean by tool.
Yeah, absolutely. And I think tools is it's something that's close to me. I built lots of tools as a tech artist, but the idea of like, you're going to have a game with a technology base. You're either going to get it from somewhere, you're going to get your Unreal Engine, or you're going to have your engineers build this. But you can have like the best, most amazing tech, but if you don't give the really talented artists and designers the tools to harness it, they can't use it to its fullest, and they can't, it becomes a roadblock for them. And so the tools layer is such an interesting role, and tools exists, I think, probably at every game and film studio, and increasingly in visualization studios, because it's filling those holes. We can't make Unreal Engine perfect for everyone, but we can expose stuff so that you can make tools and change stuff and build those things. And so the tools programmer role is such a key role in any production anymore, to take these huge, cool systems, high performance, whatever, and provide something that a designer or an artist can use in production so that when it actually gets to rendering time, it still works, and it uses the features of the renderer or whatever that is, or even fixes the issues so that whatever that tech was that we made, it doesn't perfectly work for you. A tools person can take that and make it work for your production.
Yeah.
So yeah. So
Yeah, I think you
please,
touched on two important points there. One is that the Unreal Engine does provide, I think, real advantages by having a suite of tools. That it's much bigger than just placing a few, than placing lights and placing objects, but it has tools for the gameplay scripting. It has tools for all the asset preparation. It has tools for some asset creation. It has a very wide range, wide range of tools. And the other thing that you touched on that I thought was a really good point is that it's also extensible. So that if you don't like these tools or they don't quite do what you need them to, and you have the know-how and the time, you can extend them in the ways that best suit you. But just as an example of a tool, I'm going to screen share for just like 5 minutes tops and show you something. I'll just start that up now. Flip, share. Okay, now we're sharing. So the editor, Kyle popped it up earlier. I'm not really showing you anything very exciting here. It's just an empty
I've seen
space.
this before.
But I was going to talk for a moment about asset optimization. So within the editor, we have these sub-editors. In this case, I'm looking at a character, a little mannequin that we use to play around with a bunch. And he's got bones inside of him. So he's a little rigged character. He can, let's see, do things. We will probably isn't very nice for him, but he's not doing so well. But actually, I can make it go backwards. He's doing better.
There we go.
So on the screen, up in the sort of upper left-hand corner of the viewport, you'll see it's reporting lots of information about this character. It says the screen size, but the most ones I want to draw your attention to is the triangle count and the vertex count. So that's how detailed this character is. Represents to some degree how much disk space he takes up, and we can even see he's made out of a ton of triangles. So often we'll want to use level of detail systems where we have cruder or cruder versions of the character for when you're just like really far away from him.
Mm-hmm.
We'll have fewer and fewer triangles. And here I can force it to show us like a cruder version. So here's a version that has half as many triangles. We can, of course, pop it back up to the highest res. You'll see there are some slight differences. But if we're very far away or even moderately far, this LOD1 version of the character, who still responds to the same animation in the same way, is fine. Or this LOD2 version of the character. Actually, let's make him better. There we go. So this LOD2 version of the character, he has far fewer triangles. He has 4,000 triangles. I think we started with 40,000 triangles. So he has a tenth of the original number of triangles. So takes up a lot less space, and he's much easier to draw if you're the computer. And then we can go down to level 3, and he's only got like a little over 2,000 triangles. He looks kind of crummy if we're up close, but back here looks great. So this tool that took the high poly original character and generated these lower poly versions of him that I briefly reran there for a moment to make a better version of the LOD2. That was something that I wrote, and it was written with the idea of asset optimization in mind. We have other tools that do similar things for non-moving meshes, for meshes that aren't rigged, they don't have bones. So we call them static meshes. We are developing a suite of other tools to do all sorts of geometric manipulation on things. But that's just an example of a tool that has some real impact in the game. I really enjoyed making it, and I love that when I see my kids playing Fortnite, or if I play Fortnite, I'll know that the characters in the distance went through the thing I made, and that feels awesome. So that's just sort of a sense of what that is. Here, I'll stop screen sharing because
All right.
I'm sure we're done seeing his death. But
So can you kind of just walk through, like, how do you approach making a tool like that? Do you just like dive right in, get the engine, and start coding at a tool, or do you
well,
kind of how do
fortunately,
you
we
get
have
there?
lots of tools to start with. So like one of the approaches that people take in programming is you find our engine is large. You find something that exists that's similar to what you want to do, and you look to see how that was implemented, what systems that hooks into, how that interacts. Presumably, those people are easy to contact. You can talk to them, say, this is really what I want to do. What sort of advice do you have? So some of it does require, because as I mentioned earlier, there's a lot of collaboration, just talking to people and figuring out what the right place to put something is, and how best to expose it. But that said, if somebody's just working at home or they're working on a project for themselves, I would highly recommend using a development environment that includes a debugger, so that you can breakpoint anywhere, see where you are in the code, see what's being called, what you're interacting with. There isn't a one-stop shop for I want to do tool X, Y, or Z, because the tools can be so different. Like the particle system is very different from something that's very narrow and focused, like this little tool.
Mm-hmm. Mm-hmm.
The particle system is there with Niagara. They've written an authoring system where people can author all sorts of effects, where here I've just done something that takes this little blue robot and makes him look a little bit crummier.
And so you built the kind of the math that figures out the shape and how you can take this model and reduce the number of triangles on it so that it still visually looks the same. Because if anyone's watching that's been doing game dev for more than 5-10 years, you've made a lot of LODs in your life. And one, thank you for making a tool so I don't have to make quite so many LODs in my life, because ouch, LODs are not fun to make. But just like if you take your model into Max and throw optimize on it and crank it down to, a tenth, you're just going to have a pile of triangles that looks like garbage. Traditionally I've had to like go and really manually figure out where those unimportant triangles are and pull those out. It's a very kind of creative process. So what really stunned me when these tools came out was kind of how well they kept the shape, and so it's not just like remove nth number of triangles, and that's that kind of sort of your first instinct is, oh, I'll just remove n number of triangles, optimized, good. But in the real world, you try that and your models look really bad. It might work well on a teapot where you're like, see, teapot still looks like teapot. But you throw it on Space Marine, and Space Marine suddenly doesn't look like a Space Marine anymore. So it's you kind of you build these systems, and so your history with math and understanding. I'm guessing that you really have a good grasp of like 3D space and 3D matrices
Yes, I would definitely encourage anybody who is interested in games to learn a little bit of 3D math, like vectors and a little bit about matrices and rotations, and know how to manipulate these things and what the core ideas there are, to be very have a real facility there. In the case of this project, I was fortunate in that Brian Karras, who works at Epic, had worked on the counterpart to this for the non-moving characters. So I was able to talk to him a lot about it. And there was also a research component, like how do we make something that will work well for our animated characters, respect all the bones and things like that. And that was stuff I had to sort out to see how we could do that efficiently. Make a tool that was nearly interactive, that was pretty speedy, so that artists can get real feedback and see that I can take a few more triangles out, or this other thing I need to tweak. But
I think that's great advice. I think that's really strong advice for people working with Unreal in any aspect, whether you're doing gameplay, you're programming to the engine, you're doing art, is to look at that prior art. Unreal Engine has been around for a while. We've made a lot of games with it. There's a lot of tech in there. There's a lot of thought that's gone into it. So I think your insight of when I started this, I looked at other systems that were already there that did something similar so that I can get some insight into how to solve for some of those problems, or even insight into what those problems might be, because this person's already gone through it. And then also the insight into that, you're not just jumping into code and starting to figure that out. First, you're doing research, and you're talking, and you're building a plan, because building a tool like this in an engine as big as Unreal would be, without that strong plan, you wouldn't want to have to get started and then ever backtrack. That seems like a really hard thing to do, to kind of go back from your assumptions once you've dug in so deep into something like this.
Well, you do have to, like in software development, and even in this, there were points where I had certain ideas. There was a research component, I think this idea will work, and that one didn't work so well. But then you learn in doing that, all right, I need to take a slightly different approach here. I see what my mistake was when I made this assumption. This is what I've overlooked, or this sort of case. So I'd like to say it's measure twice and cut once, but it's not. It's measure twice and cut a couple times too, because there are definitely cases where if you're doing something that hasn't been done before, or you haven't done it before, where you will have to modify, you'll make mistakes, you'll learn priorities that you didn't realize that this thing is important, and it turns out it really is. So that's part of the fun of doing software development. If you knew what you were doing and it was simply purely mechanical, then I think it would be less enjoyable. But the problem solving aspect of it requires your dealing with problems as they come up, or as they present themselves to you. And sometimes that means you have to take a slightly different tact or approach than you thought was going to be what would be successful.
One of my favorite engineers, Ove Arup, who again, Tom probably knows from architectural side of things, had an expression that design is solving a problem that can only properly be formulated once you've solved it.
That's that encapsulates many hours of my life. Where I'm like, what is going on here? And it's only once it's all there that I'm like, oh, never mind. I was wrong. And I think that's really important for teaching students programming, game, and tech in general, is that, we've got 3 guys here at Epic Games, and, David Hill's like, I make mistakes. People expect things to work. Sometimes they don't, sometimes they do. But don't fear that. Even at a professional level, you're never perfect. And the people around you are also imperfect programmers and developers as well. And they understand your struggle. We know it. So don't be afraid to make those mistakes and learn and fall
Experiment.
down. Just pick yourself back up, rewind that death animation and keep going. Because, I think, Kyle, David, all of us, I think we've all had kind of interesting careers. We didn't end up where we thought we would when we started. We either, when we signed up to school or didn't go to sign up to school, things change and the industry changes and we change. And it's, when we're getting students and developing these curriculums, it's, you'll hear it over and over when we invite people to streams or we invite them to schools, and they ask, what do we need to do? What do we need to learn? And it's problem solving. It's that's what's going to make you, get that first job. It's going to help you be successful. And then as that job changes or whatever, it'll help you move along with that.
Mistakes are a big part of that.
Yeah, and mistakes are a big part of that. Don't be afraid to fail, especially in school. Like, fail away. It's time. There's a time and a place for anything. And it's
If you're lucky, some of your tutors or lecturers may have actually made a lot of mistakes for you in the past. That's one of the things I know, working as a trainer in film industry. One of the things I said, I will break everybody's tools before they get to you. I will make all the mistakes. I will be a professional idiot, and I will find out all the things that my presumptions were wrong, and then explain to you so you don't have to make those mistakes.
Totally. So we're kind of heading towards the end of the stream here. Mark, did you see any questions in the chat that you might want to toss out there?
There was one. Why does game development still use C++ so much? It was going to come up at some point.
Great question. What do you think? Who can
question
field
about
that one?
Moving on to things like Rust.
Yeah, I can touch on it a little bit, I guess. I mean, I think there's some inertia to it, right? I mean, there's a huge amount of legacy code, and the transition cost is really high. Some of it, C++ is well supported. The tooling is great. It's big and it's complicated, but it's also incredibly powerful. And in a lot of ways, that power is absolutely necessary. Game development is a really interesting mishmash, or just this intersection of requirements where we want to look awesome, we want these really complex simulations, we want these crazy next gen visual effects, and we want it to run in a 60th of a second, right? go on an iPhone, come on. So I think we need access to that power, and you don't use it every day. I'm not micro optimizing gameplay code, but there are places that need it, and so I mean, will that change in the future? I'm not sure, but I think it would take something pretty earth-shattering to break that inertia. I think we're in a situation where what we have works pretty well. It's not without downsides, but its upsides are good, and it's proven successful.
Mm-hmm.
Yeah, it's at this point it would be pretty tough, even if something came along that was demonstrably better. To move all of the tools and technology that have been built over the decades over to whatever that is, and to integrate it would be it would have to be so much better for that cost to be burdened.
Yeah, I think any changes will be incremental. You can think of something like Blueprints. I'm not gonna have with Blueprints obviously, but if you think of Blueprints as a programming language, and it's a small bubble, and maybe that if it's wildly successful, that bubble would grow, right? Or some other programming language has a use case, and then it expands and just sort of overtakes it. I don't think we're all just going to flip a switch one day and go, well, we're doing Rust today.
C++ is out finally.
Yeah. Did the question suggest a different language? I'm curious if they.
It was mentioning Rust.
Okay.
And I think there's the engine code and the tool code that benefits massively from some of the things that C++ does, just from performance, memory-wise, scalability, etc. But I think the question gets much more ambiguous when you get to gameplay, scripting, and programming. That becomes, like you said, you're not micro-profiling gameplay code, and that's I think that's where there's opportunity for there to be more types of code, and for more kind of experimental stuff that fits the needs of gameplay programming, may be better than C++ does, but certainly for high performance computing and getting the most bang for the buck out of the hardware, C++ is kind of still the king.
Yeah, I mean, that's where stuff like Blueprints comes in, because I mean, it's not about, it has a performance cost, but its acceptable performance cost for the benefits and expressiveness and iteration, and if the end goal is to make a game, to make a product, right? Like you're trying to get there as fast as possible. The method to get there, if you were 10% faster, if your blueprint kind of ran 10% faster, but it took you a year longer to write it, that's a loss. Right?
There was one other question here, which may have been somewhat in jest. Do you think that AI will actually replace you as programmers?
I think
I'll
it'll
just
move
write
us,
the AI.
yeah, it'll move us up a level, right? That's all. It's just
Yeah.
one more level in direction.
It'll replace all programmers except for AI programmers because they'll build
Exactly.
in the back door where it just can't learn to
Yeah.
teach itself AI
So-
programming.
So just make sure your T covers AI. It's on the
Well, guys, I want to thank you all for joining us today. This was really fantastic. Such cool stories, such great insight into what we do at Epic Games, building Unreal and Fortnite. And thank you so much for sharing what you do, sharing your stories, and helping our educators and our education community. Skill up. They appreciate all of the knowledge we provide each week. It's a real privilege for us to be able to expose this stuff to this community. So thank you so much for coming, and thank you all for joining us this week. Little housekeeping at the end here. We will not have an educator stream for the next 2 weeks. We are on summer vacation. Woo! So we will see you in 3 weeks. And stay tuned to the forums to get some more information. We've got some really cool streams coming up with some character artists and some technical designers, rendering, and all the great stuff. So
We should get some sound people.
that is a great idea.
We should.
Yeah. Put that on the
They've got some-
list.
They've got some cool stuff in the
On
pipe.
the list.
They do, and
Yeah.
and audio is something I am not very good at, so I am really curious to have someone demonstrate it.
We'll
So
do
yeah,
that.
thank you all, and we will see you in a few weeks. Have a great summer break, everybody.
Thanks, everybody.